Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through independent and mutually exclusive events. So let's start with mutually exclusive events, and we'll start by drawing a Venn diagram. So we learned last time that probability of A union B means probability of A or B, and it includes these three numbers inside the Venn diagram. So it would just be 7 plus 11 plus 6, which is 24 out of 32 in total, right? What we're going to do is come up with a formula for probability of A or B in terms of the probability of A, the probability of B. So I could have got this by taking the probability of A. So the probability of A here is everything inside the A circle, so that's 18 out of 32. So I would have also had to include the probability of B. So the probability of B is 17 out of 32 because there are 17 inside the B circle. But what you would notice is if I find A or B by adding the probability of A with the probability of B, I've double counted what's in the center. I've counted these 11 twice. So I would need to subtract 11 out of 32. And you can see 18 out of 32 plus 17 over 32 minus 11 over 32 does give me 24 out of 32. Why am I going through all this? What I've just showed you with the Venn diagram is probability of A or B is the probability of A, all the things in A, plus the probability in B, but I need to subtract the probability of A and B. I basically need to add up what's in the A circle, what's in the B circle, but subtract what's in the middle because I've double counted that. And that's what I did up here. 18 plus 17 minus 11 equals 24, and the probability of A or B is 24 out of 32. So this is the first rule we need to know from today's lesson. It's called the OR rule because this is read as probability of A or B. Probability of A or B equals the sum of the probabilities of A and B minus the probability that they both happen. So what's all this got to do with mutually exclusive events? So we say that two events are mutually exclusive if they can't both happen. So for example, you getting an A in maths and you getting a B in maths, they are mutually exclusive. You can't get an A and a B, only one of them can happen. If you roll a die, you can't get a 3 and a 6. They are mutually exclusive events. So mathematically, we say that two events A and B are mutually exclusive if the probability that they both happen is equal to 0. So again, mutually exclusive means they can't both happen. So when they're mutually exclusive, we slightly modify this rule here. So let's say A and B are mutually exclusive. So this rule here is exactly the same as the OR rule above. But if they're mutually exclusive, I can rub out this end part here because it's 0. Probability of A and B is 0 if A and B are mutually exclusive. So if two events are mutually exclusive, the probability that either of them happens is just the sum of the two probabilities. And I can use this rule together with the original OR rule to make quick probability calculations. So let's look at a few examples of this. So let's say I draw a card from a normal deck of 52 cards, that means no jokers, and I'm going to find the probability of each of these things. Notice all of them involve the word OR because this is the OR rule. It's about unions. So firstly, the probability of a king or an ace. So these are mutually exclusive. You can't pick a card that is a king and an ace. So to find the probability that I get a king or an ace, I just find the probability of king, probability of an ace, and add them together. So 4 out of 52 kings, 4 out of 52 aces. The answer I get is 8 out of 52 because I just add them together, and that simplifies to 2 out of 13. Easy as. All right, let's do the second one. Probability you get red or spades. So again, these are mutually exclusive. You can't get a card that is red and also spades because spades is black. So the probability you get a red card is a half. Probability you get spades is a quarter. There are 4 suits. Spades is one of them. So the probability you get one of those is 3 out of 4. You just add the probabilities together. How easy is that? So for the next one, the probability of black or a 5. Now notice these are not mutually exclusive. You can get a card that is both black and a 5. So we need to add their probabilities together like we did earlier, but we need to subtract the probability they both happen. The probability I get a black card is a half. It's either black or red. The probability I get a 5 is 4 out of 52, but I need to subtract the probability that they both happen. So in the deck, there are 2 black 5s, the 5 of clubs and the 5 of spades. So I need to subtract that. And I get 28 out of 52, which simplifies to 7 out of 13. So for the last one, note they are once again not mutually exclusive because you can pick a card that is both 10 and diamonds. That's, of course, the 10 of diamonds. So to find the probability that I get 10 or diamonds, I add together the 2 probabilities and I need to subtract the probability I get both. So the probability that I get a 10 is 4 out of 52. There are 4 10s in the deck. For diamonds, it's 13 out of 52 or 1 over 4 because there are 4 suits. One of them is diamonds. Now, the probability I get a 10 and a diamonds, the probability I get the 10 of diamonds is 1 over 52. So, adding that up, we get 16 over 52, and that simplifies to 4 over 13. All right, how easy is that? Now we're going to look at independent events. And if you're wondering, there is a corresponding rule for probability of A and B. So in probability, we say that 2 events are independent if neither affects the chances of the other. So for example, the 2 events, 1, tossing a coin and getting heads, 2, rolling a die and getting 4, they are independent. Whatever happens on the coin doesn't affect your chances of getting a 4 on the die. They don't affect the chances of each other. So in blue, these 2 events are independent. So in grey, the 2 events are not independent, they're dependent. I study for my maths test and I attain an A in my maths test. So note, these are not independent, they are dependent. It doesn't mean that I'm saying that if you study for your maths test, you absolutely will get an A in your test. The reason they're not independent is because studying for your maths test does affect your chances of getting an A in the test. You're more likely to get an A in the test if you study. So that's what we mean by independent. So there is a corresponding rule for independent events, and it involves the probability of A and B. So if 2 events A and B are independent, the probability they both happen, probability of A and B, is just the product of their respective probabilities. So note, when we were doing the OR rule, it was still possible to find the probability of A or B, even if they weren't mutually exclusive. However, if 2 events are not independent, we don't have a way to find the probability they both happen. So you can only use this rule if the 2 events are independent. Let's look at a few examples. We will now use this rule to calculate the probabilities in each of these cases. So firstly, if I toss a coin and roll a die, what's the probability I get heads and a 4? So I've already discussed that these 2 events are independent. So the probability I get heads is half. The probability I get a 4 is 1 over 6. So the probability I get both of those, because they're independent, I just multiply them together. And I get 1 over 12. All right, the second one. So randomly pick 2 cards, one after the other with replacement. So that means I pick a card and then I put it back and pick another card. So because I'm doing this randomly, what I get the first go doesn't affect my chances what I get the second go. So the first pick and the second pick are independent. The probability I get diamonds the first go is a quarter. The probability I get diamonds the second go is a quarter. So the probability I get both, I just multiply the probabilities and get 1 over 16. All right, for the last one. If I roll a die, what's the probability I get a number greater than 4 5 times in a row? So if I roll a die, the probability I get a number greater than 4 is 2 over 6 or 1 over 3. So the probability I get that 5 times in a row, each time I roll the die is independent of the previous go. What I get at the first go on the die doesn't affect my chances of what I'll get the second go on the die. So the probability I get a number greater than 4 5 times in a row is a third times itself 5 times. Of course, the easy way to do that is just raise this to the power of 5, and I get 1 over 2, 4, 3. Okay, now we're just going to do a couple of examples that involve both independent and mutually exclusive events. Let's look at this question here. I must pick 2 students to win a prize out of a group containing 4 Year 8s, 5 Year 9s, and 3 Year 10s. So I can pick the same student twice. The same student can win both prizes. What's the probability both prizes go to students in the same year levels? So what I'm really asking is, what's the probability that I pick 2 Year 8 students to win the prize, or 2 Year 9 students, or 2 Year 10 students to win the prize? So because these are mutually exclusive, I can't pick 2 Year 8 students and 2 Year 9 students, because I'm only picking 2 students all up. So this will just be the probability I pick 2 Year 8 students, plus the probability I pick both Year 9 students, plus the probability I pick both Year 10 students. The reason I'm adding these together, they are mutually exclusive events. So the probability one of them happens is just the sum of all their respective probabilities. So now I want to calculate the probability that I get both Year 8 students. So as long as I pick this randomly, each time pick it randomly, these events will be independent. Because whatever I pick the first go, if I pick the second go randomly, it won't matter what happened on the first go. They don't affect each other. So the probability that I pick 2 Year 8 students, so the probability the first student is a Year 8 is 4 out of 12, or 1/3. Probability I pick a Year 8 on the second go is 1/3, because I can pick the same student twice. So the probability they both happen, because they're independent, is 1/3 times 1/3. Similarly, the probability I pick a Year 9 student the first go is 5 out of 12. Probability I pick second go is 5 over 12. These are independent, because if I pick it randomly, it doesn't matter if I got a Year 9 the first go. I have the same chance of getting it the second go. And similarly for Year 10s, probability I pick a Year 10 the first go is 3 out of 12, or 1/4. Probability I pick a Year 10 the second go is 3 over 12. We times them together because they're independent. So this is the probability I get both Year 8s, both Year 9s, both Year 10s, and I add them up because they are mutually exclusive. So I get 1 over 9 plus 25 over 144 plus 1 over 16. So the answer I end up getting is 50 over 144, and we can simplify that to 25 over 72. Okay, so that's the probability that I will pick students from the same year level to win both prizes. So I used independent events to calculate each of these probabilities, and then I added them all up by using mutually exclusive events. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.